Our topic for today is still under AC circuit, and of course, the conclusion part of the AC circuit that we have started since last week. Then, before we go on into today's topic, we are going to complete the solution of the question that we are unable to complete in our last video. Now, the question says a 10 microfarad capacitor is connected directly across a 100 V root mean squared 50 F source. Determine the capacitive reactance in the circuit, hence find the high root mean square. Now, what you first of all do is convert this one to farad, which is 10 times 10 raised to power minus 6. Then frequency is 50. Then V root mean square is given, that is 100 volt. Then from the formula that says capacitive reactance is equal to 1 over 2 pi Fc. Then our 2 times pi is, let's take pi to be 3.143, then multiply by frequency, which is 50, multiply by capacitance, which is 10 times 10, 10 times 10 raised to power minus 6. So by the time you find the reciprocal of all this one, so you are going to get 318.2, and it will be in what? Ohm, because it's what? It's just like resistance in the circuit. So after this, the question says hence find high root mean square. High root mean square, just like when you have V root mean, just like ordinary voltage that you have from Ohm's law. V is equal to IR. So if this one change to V root mean, this one also will change to I root mean. Then since we are dealing with capacitive reactor or capacitor, so you replace R with this. Therefore, our formula will now be V root mean square is equal to I root mean square multiplied by XC. So you make this I root mean the subject of formula. Therefore, I root mean square is equal to V root mean square over this capacitive reactant, that is this value. And V root mean square is given to be 100. So you are going to have 100 divided by the value you got for capacitive reactant, which is 318. Calculate your own and see if you are going to get the same value. So that is the end of the uncompleted calculation in our last video. Now let's go on for today's topic. For today's topic, the first thing is a reactant. Let's start again from reactants, and let's first of all revise everything in general. I said in AC circuit we have 3 devices that receive the flow of current. The first one, we have resistor, we have capacitor, we have inductor. That of resistor is called resistance. Capacitor is called reactant. Inductor is also called reactant. Then if you now have the two in the circuit, it still remains what? Reactant. The symbol for that of capacitive reactance, we have C. Inductive reactance, we have this. But if you now have the two in the circuit, which is also what? Reactant, the result is reactant is equal to, you subtract that of capacitive from inductive, that is XL minus XC. So that is that about when you have two of them, capacitor and inductor. So in that case, it's not yet impedance. It's only when you have resistor in the circuit we have impedance, and it was not what? Resistor only. Now, when you have a capacitor and inductor, we call it reactant. When you now have capacitor and resistor, so in that case, we have our impedance. We call it impedance. If you have resistor and capacitor, it is what? Impedance. If you have resistor and inductor, we also call what? We call it impedance. But if you have resistor, capacitor and inductor is also called impedance. Impedance in this case, for this one, our impedance is equal to, let's say, impedance square is equal to R square plus XC square. But for this one, we have impedance square is equal to R square plus XL square. But in this case that we have the two together, we have impedance square is equal to R square plus XC minus XL everything square. Therefore, if I want to define impedance in the circuit, is the opposition over to the flow of AC circuit by resistor and capacitor, or resistor and inductor, or resistor, capacitor and inductor. Therefore, before you can have impedance, there must be what? Resistor there, and it must not be only resistor. Then what will now be the phasor diagram for them? I will call it vector diagram. So in that case, when you have this like this line replace only resistor R. Then this one will be VL. Why this? I mean XL. Why this one is what? XC. Then by the time you subtract this one from this, it still remains vertical. You now bring it here to form a right angle triangle. The result of this and this will give you here. That is XL minus XC. Then when you have something like this, you use Pythagoras theorem to get what? Resultant. And that resultant is called impedance. This is impedance. Therefore, to get the impedance, we have impedance square is equal to R square plus XL minus XC everything square. So if you are looking for this, just find the square root of both sides. That is Z, that is impedance, is equal to square root of R square plus XL minus XC everything square. So we can, it's still applicable to the voltage. The voltage in RCL circuit, we call it RCL circuit. That is circuit that contains resistor, capacitor and inductor. So in that case we have a total voltage in the circuit will equal to the voltage through resistor plus voltage through impedance, inductor L minus voltage through capacitor C, like this square, then you square this one. So you just find the square root like we did for impedance in case of don't forget, since impedance is also what? It's also mentioned in ohm. It's also mentioned in ohm. Let's go to the phase angle. You may be asked to calculate the phase angle. They mean the angle between the impedance and the resistor. Have it like this. This one is R. Then this is what? This one is XL minus XC. So this is impedance. This is what they call phase angle. If you have to calculate phase angle, you can use this over this, which will give you what? Cos theta. Then you can use this and this, which will give you what? Sin theta. Or mostly they use this and this. That is what? Tan. So tan theta to get the angle is equal to opposite over adjacent. That is R over XL minus XC. So whatever you get here is called phase angle. It's called phase angle. Then resonance. Resonance in AC circuit. When we say resonance in an AC circuit, we achieve resonance when you have maximum current. Then under the resonance, we have almost 3 or 4 things that they can ask you to show that the circuit has already reached what? Resonance stage. And then there's no need to cram it. So resonance occurs when the capacitive reactance is equal to inductive reactance. In that case, we are going to have maximum current in the circuit. And don't forget, we said let's prove it. Let's derive it and see. Let's say we have in the circuit, it said resonance occurs when the capacitive reactance is equal to inductive reactance. And don't forget, the total resistance or the total opposition to the flow of current is called impedance, which is equal to square root of R squared plus XL minus XC. Now, if this and this are equal, what will now happen? So it means the opposition to the flow of current will be left with only resistor. So therefore, this one is equal to square root of R squared. Imply that at this we have what? R. Now, what are the conditions for resonance? Like I said, so I can say under resonance we have maximum current as condition number 1. Condition number 2, capacitive reactance is equal to inductive reactance, making 2. Then the third one is only resistor that is serving as opposition to the flow of current, making 3. Then the fourth one is the impedance is equal to resistance. The impedance is equal to resistance, making 4. Very simple. So you can get it, can get everything from this formula. Now, they may not ask you to calculate that resonance frequency. Resonance frequency. Resonance frequency is the frequency at which capacitive reactance is equal to inductive reactance. You can easily prove it since capacitive let's say inductive reactance is equal to 2 pi FL and capacitive reactance is equal to 1 over 2 pi FC. So since this and this are equal, it means this one and this one are equal. So it means 2 pi FL is equal to 1 over 2 pi FC. Cross multiply, it means 4 pi square F square LC is equal to 1. So you divide both sides because our target is to find this F. Divide both sides by 4 pi LC. Therefore, F square is equal to 1 over 4 pi square LC. So find the square root of both sides. So we are going to have F is equal to, since square root of 4 is 2, square root of pi square is pi. So you factor it out, the 1 over square root of 1 is also 1. So find the square root of 4, 2. Find square root of pi square is pi. Then this one, this and this, they don't have square root. You place the square root on them. That is LC. So this is what? This one is called resonance frequency. And from here, you can easily cross multiply and get another formula. Therefore, you have 2 pi F is equal to 1 over square root of LC. Then where this 2 pi is omega, don't forget. Therefore, omega is equal to 1 over square root of LC. So take note of all these formula whenever you need it, so you make use of them. Now, let's round up the class with this question. Now, question number 1 says, determine the reactance in the circuit with capacitance 5 microfarad and inductance 10 Henry. If the frequency in the circuit is 100 X over pi, or 100 over pi X. Now, in that case, the question said determine the reactance. So they did not even specify, because in the question we have capacitor, we have inductor. So in that case, it's talking about the two together. So we cannot say capacitive reactance or inductive reactance. Now let's start and see, calculate them one after the other. For the reactance, in that case, we have X is equal to XL minus XC. Then let's calculate this one separately. Our XL is equal to, which is 2 pi FL, which is equal to 2 times pi times, what is F? F is given 100 pi, 100 over pi. Then multiply by L. L, that is 10. So this pi cancel this. So in this case, we are going to have 2000 ohm. Then let's calculate that of inductive, capacitive reactant, which is equal to 1 over 2 pi FC. So which is equal to 1 divided by 2 pi multiplied by F 100 over pi times C. What is C is 10 microfarad. That is 10, 5 times 10 raised to power 5 times 10 raised to power minus 6. So from here, you can simply cancel this one and cancel this one. So this one will give us 200. Don't forget this one, we can raise it up, which will give us 10 raised to power 6 over this 200 times 5. That's 1000. That is 1000. Then this one, we can now cancel 1, 2, 3. So we cancel 3 there. This one will give us 1000. 1000 ohm. Then the capacitive reactance now go back. That is 2. This one is 2000. 2000. So it will now be 2000 minus 1000. So our capacitive reactant is equal to 2000 minus 1000. So the answer is 1000 what? Ohm. So that's that about that. Then the next question says, at what frequency will a 30 Henry inductor have a reactance of 100 ohm? At what frequency? So in that case, we write down the formula for what? Since this one is what? Inductance. Then they gave us what? This value is inductive reactance. That is 100. Now see, inductive reactance, that is XL is equal to 2 pi FL. So inductive reactance is given. That is 100. 100 is equal to 2 times, let's take this one to be 3.143 times F. That's what we are looking for. F multiplied by L. What's our L? This one, inductor, that is 30. So in that case, we can cut this and cut this. So we can cut this and cut, that is 5. So therefore, 5 is equal to 3.143 times 3 times F. So at the end of the day, our F is equal to 5 over 3.143 times 3. So you multiply this one and press the final answer with your calculator. That is an assignment for you. So whatever you get will be in